Take a deep look into a couple of the polyatomic ions, the oxyanions, okay? All of these have a structure where I have a non-metal. It could be chlorine, nitrogen, sulfur, phosphorus. You have the table of all the oxyanions, and they're attached to multiple oxygens, forming a polyatomic ion with some charge. It might be -1, it might be -2, it might be -3. And there are various numbers of oxygens up to 4, as in perchlorate. Okay? Now the compounds with the greater oxygens end with an 8. The compounds with the lesser oxygens end with a 9. And later on we'll see that it has to deal with the oxidation state, the sort of charge state of the non-metal in the center. Okay? But right now we can memorize that the ones with the more oxygens are 8s. And perchlorate has more than chlorate, and hypochlorite has less than chlorite. So these down here are the ites, the 8s. Now, it doesn't tell us how many oxygens there are, okay? So nitrate has 3 oxygens, while sulfite has 3, and sulfate has 4. But there's more in sulfate than sulfite. There's more in nitrate than nitrite. The other thing we need to know is, what is this charge over here? Now, with the exception of nitrogen, okay, this is the exception, okay, the charge of the binary ion, the monatomic ion, is the same as the oxyanion. So chloride is -1, therefore all the oxyanions of chlorine are -1. Phosphide is -3, so these are -3. Sulfide is -2, so these are -2. But in the case of nitrogen, this is different. Nitride is -3, okay? So you need to remember that nitrate and nitrite are -1. But for all the others, you can simply just look at the monatomic ion and realize that the polyatomic ion has the same charge.